How do you calculate exergy destruction in a thermodynamic process? Have you ever wondered how we can measure the loss of useful energy in a thermodynamic process? Today, we will uncover the concept of exergy destruction and how to calculate it. Exergy destruction helps us understand how much useful work potential is lost due to various inefficiencies in a system. This loss can occur from factors like friction, heat transfer, mixing, or even chemical reactions. To calculate exergy destruction, there are two main methods that are quite straightforward. The first method involves using the Exergy Balance Equation. This equation takes into account the exergy entering and leaving the system through work, heat, and mass flows. To find the exergy destruction, you need to look at the difference between the exergy input and the exergy output. The formula is simple. Exergy destruction equals exergy in minus exergy, out plus exergy lost by heat transfer minus work output. If you know the initial and final states of your system, along with the heat and work interactions, you can calculate the exergy change. This will help you determine the exergy destruction. The second method is based on entropy generation. This approach relates exergy destruction directly to the entropy generated within the system. Since entropy generation indicates irreversibility, you can find the exergy destroyed by multiplying the ambient temperature by the total entropy generated. The formula looks like this. Exergy destruction equals ambient temperature multiplied by entropy generated. In this case, the ambient temperature is measured in Kelvin, and the entropy generated is the total change in entropy during the process. This method can often be simpler because it focuses on calculating entropy generation, which can be derived from the entropy balance of the system. It is essential to remember that entropy generation arises from irreversible processes such as friction, unrestrained expansion, mixing, heat transfer with finite temperature differences, and chemical reactions. The ambient temperature is crucial because exergy is always measured relative to the environment. Exergy destruction is always a positive value or zero. A zero value indicates a reversible process where no work potential is lost. To calculate entropy generation, you apply the second law of thermodynamics to find the difference between the entropy outflows and inflows, plus any changes inside the system. For a practical example, consider a heat exchanger. In this scenario, the hot fluid loses exergy while the cold fluid gains it. However, the total exergy decreases because some of it is destroyed due to irreversibilities. By calculating the exergy change of both fluid streams and adding them together, the negative sum will give you the exergy destruction in the heat exchanger. In summary, to calculate exergy destruction in a thermodynamic process, you can either perform an exergy balance using known states and energy transfers or calculate entropy generation and multiply it by the ambient temperature. Both methods provide a clear measure of the lost potential to do useful work due to irreversibility.